Hello everyone, welcome to the live class. So guys, today we are going to have another very important session in which we will be discussing some more important questions and very important concepts for the upcoming CSIR NET and the GATE physics exam. So we will be doing the discussion about the most important questions and concepts of classical mechanics in this session, and I hope each and every point which we will consider in the session will get clear to all of you. But in case anywhere if you will be having any doubt, you can surely let me know about it and we will try to consider those points as well. Okay, so we are just going to start the discussion about all these important points in few seconds, and I'm just going to check it out whether everything is all right and clear your side or not. I think everything is all right now. Very good afternoon, Suchishmita. Very good afternoon, everyone. So we can continue the discussion and we can talk about the important points. So first of all, I would like to show you the slide regarding the Unacademy Plus and the Iconic subscription. As you can have a look at this, if you will be taking the Plus subscription, then you will be getting these benefits. If you will be taking the Iconic subscription, then you will be getting these benefits. Depending on which one you find more beneficial for you, you can take that subscription. And whenever you will proceed further to take the subscription, you can use and apply the referral code, that's Anjali A Live, as mentioned here on the screen. By using and by applying this referral code, you will be able to get the 10% discount in the total subscription amount. Take care, Suchishmita, and get well soon. And guys, if I'm going to talk about the courses and the sessions which we are going to have on Unacademy for the upcoming exam preparation, in that case, these courses will be helping you to do the best preparation in very less time under the guidance of top educators, and will be helping you to be more confident about your exam preparation and to know about the right approach to solve the questions as well. So this is how everything will be helping you guys. I hope each and everything which we have discussed here regarding the Unacademy subscription will be clear to all of you. And even in upcoming days, many new courses by the top educators will also be starting on Unacademy. So you can take the subscription. And even if you will be taking the subscription right now, you will be able to join the ongoing courses sessions, the upcoming courses sessions, and even if you have missed any sessions earlier, you will be able to check out the recordings of those classes as well. It's okay, Suchishmita. Take care, take rest, get well soon, and then you can continue your preparation. You can join the sessions, okay, once you will be feeling better and you will be ready to join the sessions. That's okay. So guys, today's session will be about the classical mechanics most important concepts and most important points. So in today's session, I'll be covering different concepts and different type of questions from classical mechanics section. And the points which I will cover up here will be helping you a lot to solve many questions of classical mechanics, and just in very less time we will be able to cover up all these important points, all these important concepts. Even somewhere we will try to include the tricks as well. So what are these tricks, what are these concepts, what are these important points? You will soon get to know about them in the session. Just attend this session till the end and don't miss it. So you will be able to get each and everything. Now let's start the discussion. Or even if you are the one who has already prepared the classical mechanics part and knows about many topics, many concepts of classical mechanics, in that case, this session can help you even to revise those concepts in very less time. Okay, and even some of the new points you can get to know in the session itself. So let's just start the discussion now. I will be considering the things in such a way that there can be many students, those who are just starting their preparation for classical mechanics now, and they have not prepared the subject earlier. So in that case, from where we need to start, what are the points and the concepts we need to discuss, all that we will be considering here itself. So you don't need to worry about it even if you have not prepared the subject earlier. Okay, firstly, I would like to start the discussion with the Lagrangian part. What are the things you need to know about the Lagrangian? I'll be including all of them here after attending this session. Even if you want, you can check out some previous year questions, the tricks which I will be considering here. If you want to apply them, you want to check them by applying in the questions, the previous year questions, you will also be able to do that, and that will become more easy for you to consider. Okay, so Lagrangian. About Lagrangian, few important points are there which everybody needs to know. But what are these important points? Let me just tell you. The first one is Lagrangian is a function of generalized coordinate, generalized velocity and time t. At the same time, if I'm going to talk about the Lagrangian, that's simply going to be kinetic energy minus potential energy. But the first point, that's very much important. If you take it lightly and you say like, oh, it's very basic, it's like something, it's a function of which parameters. But this point is even very important, and sometimes it can help you to avoid making any kind of mistake in the exam. So it's important, okay? Second thing is Lagrangian is kinetic energy minus potential energy. Clear? Now, what about the next point here we have to consider? Related to Lagrangian, there is Euler-Lagrange's equation of motion. What is that? That's simply equation of motion which will be helping us to solve different type of questions, even to consider if we are having a proper system given to us in a question and we want to get some information about the system. We want to get the information about the particle present in the system, and we want to know at what height the particle will be stationary, and we want to know that where the particle will be moving with this particular speed. So these are the different situations, these are the different cases, and to know about them, what do you have to do? You just have to consider the equation of motion, and that's how you will be able to work on these things. Means wherever it's possible and it's easy for you to write the kinetic energy and potential energy, and easily you can write the Lagrangian, you can go for equation of motion and you can get the information about the system, anything, whatever you want to know. So this is the solution of all these different type of problems, and that will be helping you a lot to solve the questions quickly, easily and in less time. So let me just tell you about it. It's gonna be d by dt delta L upon delta Q dot minus delta L upon delta Q equal to 0. This is the equation of motion. But there is something important I would like to add here, which is generally not so common, and even from there we didn't get so many questions in the previous years. But in case if you will be getting it, so it can help you a lot. In general, we all know F is equal to minus delta V. Okay? Or net force, when we consider how we write it, like everybody knows about it. Okay? So in that case, F is equal to minus delta V now. So if I want to write the generalized force, F generalized means I want to know about the generalized force. In that case, at place of L, I will just have to write the potential. That's it. I have got that expression, and this is how you can easily memorize it too. So what I have done, once I will be preparing the equation of motion just by replacing the Lagrangian with the potential, I will be able to get the expression for the generalized force. I hope you are getting it. But in case if you are going to have any doubt or difficulty anywhere, you can mention that too. If we are going to talk about the next point here, what is that? Let's talk about it. If in case you will have any questions, any queries, any doubt anywhere, just mention it. The next point is again related to the Lagrangian, but that's about the important formulae, important relations. You can see there is no momentum term present in this Lagrangian, as it is just a function of generalized coordinate and generalized velocity along with the time t. So in this case, anytime if we have got or we are going to get the momentum term present there, then what we will have to do? What we will have to consider? So for that, we should have the generalized momentum formula, which is simply delta L upon delta Q dot. P is equal to what? Delta L upon delta Q dot. So anytime if you want to replace momentum, you want to find momentum from the Lagrangian, like anything like that you want to consider, or you want to get the relation between P and Q dot, so this formula will be helping you there. Clear? It's very much important. So as I have told you, if you are attending this session, you are going to get so many points today. You will be able to prepare so many concepts today in just very less time. So this will be surely helpful for you. Now, once you got to know about this point, what about the next point, which is important and which everybody needs to know? So that is about the action. What is the action actually? Action is the time integral of Lagrangian, which means integration L dt. Okay, that's so simple and easy. You may have heard about the least action principle. Same way here, just to define the action, what we need? The time integral of Lagrangian. T0 to Tn I can write here, and that's what? This is the time integral of Lagrangian, which will be considered as the action. Okay, this is important as well. Now, after knowing about these many things, the next thing you need to know is, if Lagrangian is not a function of time t, if Lagrangian is not dependent on time t or does not depend on time explicitly, what is the meaning of explicit dependency? Okay, let's talk about it. Does not depend on time, that's to explicitly. What is the meaning of this term? This means actually the t is not present there. So if I'm going to talk about the expression, for example, L is equal to half m x dot square minus mgy. So here you can see t is not directly present. T is something we can't see in the expression. So here there is no explicit dependency on time t. Okay, that's what you have to consider. At the same time, if I'm going to write the t here, now it is dependent on time explicitly. It's just the random expression I'm writing. It's not something you will be getting again and again. You are going to have like, no, it's just a random expression just to explain the explicit dependency on time t. I hope everybody is going to get it. Excuse me. Done? Right, Suchishmita. Delta this fx is equal to 0. Delta this fx is, M3, I think you are talking about the stability analysis concept. We will also be talking about that when we will talk about that particular topic or the concept, then we will consider that as well. But right now, we are just mainly going to consider the points related to Lagrangian. So there we consider the first order derivative and different concepts, different expressions like that. Okay, we'll talk about that as well. So guys, this is how you are going to know about this thing, that how, see, when the Lagrangian does not depend on time explicitly, it means the energy of that system for which you have mentioned the Lagrangian will be conserved. The energy of the system will be conserved. That's again the very important point we are going to have. And if you will be like focusing on this point, you will easily be able to solve any such type of question, and most of the questions which you will be getting from the Lagrangian part related to the Lagrangian topic will be from this section. One more like thing we will be considering here. What is that? That is the cyclic coordinate or ignorable coordinate thing. Now what we mean by cyclic or the ignorable coordinate and what are the points about that we need to know, let's talk about it. Look at this. For example, you are going to have L. L means what? L means the Lagrangian. In this case, you are going to consider it as half m x dot square. Okay, then mg x, for example, and then I'm going to write plus m y dot square. So I can also write this y dot square term here. But let's say I have written that at the end, that's okay. Done. So in this case, you have to observe one thing. I can also write this expression this way, that is my dot square minus mgx. My dot square minus mgx. Don't consider the expression that it will always be this way or that way. No, it's just a random expression to understand the concept. Okay. So in this case, you can see one thing, that the derivative of x is present and x is also present here normally. Along with its derivative, the x is also present here normally. Means if I will take the attendance, x is present, yes. X dot present, yes. Y present, yes. Y, no, y is not present actually. Y present, no. Y dot present, yes. So if you will see the pair means x and x dot together, y and y dot together. So in this case, which one will be considered as the cyclic coordinate? The coordinate whose derivative is present in the Lagrangian, but the coordinate itself is not present there. Which means this one, if you will see, its coordinate is also present and the derivative is also present. So can we call it cyclic? The answer is no, it's not cyclic or it's not ignorable. At the same time, if I'm going to talk about this one, y is present at the same time y dot is present. Can we, no, y is not present but the y dot is present. So it is known as the cyclic coordinate, or can be considered as ignorable coordinate. But the point is, okay, we got to know about it. What is cyclic or ignorable coordinate? But will it be helping us anyway? The answer is yes. How it will be helping us? Because its corresponding linear momentum will be conserved or constant of motion. What I mean by that? It means for this expression, if I will in general talk about it, the py, that is the y component of linear momentum, will be conserved or constant of motion. Please let me know in case if you are still gonna have any doubt anywhere, we'll talk about it, okay? And if everything is clear, that's great. So have a look at this. Lagrangian cyclic ignorable coordinate concept clear? What it will tell you? The conserved component of linear momentum, okay? That information you will get. Does it, when it does not depend on time explicitly, energy conservation it tells you. It's a function of which coordinates you get to know. Standard formula for Lagrangian you got to know. Equation of motion, Euler-Lagrange's equation of motion, anything you can call it, you got to know. Generalized momentum, you got to know. Generalized force, you got to know. We have talked about it. Action, you got to know about that. So you can see how many important concepts we have considered. Now let me just check out your comments quickly, and then we will be talking about all these points as well. So let me just check it out. Total energy will be conserved, right, Sujashmita? If one coordinate is cyclic, the corresponding linear momentum is conserved. Very good, Sujashmita, that's correct. This is how it will happen, and this is how we get to know about the conserved quantities. In case anybody is gonna have any doubt, you can just mention it. I think this is not that much clear right now. Let me just zoom it a little more, little more, little more. Is it clear? I think it will be better now. Okay, done. In case if anybody is gonna have any question, any query, any doubt, anything which is not clear to you, something you want to ask, you can surely let me know about it. And if everything is getting clear to you, then that's great. So now actually you are ready to solve many questions. But before starting the questions now, I would like to discuss few more points. Reason behind it. You are ready to solve many questions, but I want you to solve more and more questions. So for solving more and more questions, we need to know more and more concepts. So for that, I need to tell you more concepts first before I will start taking the questions. And even like right now, we are going to have this classical mechanics session. After this also on Wednesday and on Friday, we'll be having the classical mechanics session itself. So we will be doing the important discussion there as well. We'll be taking more important concepts, more important questions, more important discussion. That's how we'll have our next session too. Let's keep it aside for just some time. And let's talk about the Hamiltonian. Okay, ready? I hope you are. So if I'm going to talk about the Hamiltonian now, what are the important points about the Hamiltonian we need to know? Let's talk about it. So the first thing about, same way as we have made those like connected lines and then we have just considered all the properties of Lagrangian now, same way we will be talking about the Hamiltonian as well. So Hamiltonian is here. First thing, that's going to be Hamiltonian is a function of generalized coordinate, generalized momentum and time t. Coordinate, momentum and time t. It's important. Its formula is kinetic energy plus potential energy. You can also compare the expressions. Its equations of motion are, they are just going to be, the two equations of motion are there. Q dot is equal to delta H upon delta P and P dot is equal to minus, P dot is equal to minus delta H upon delta Q. Okay, this is what we are going to have. At the same time, if we will talk about this one, that's gonna be these two expressions. Like there we had just the generalized momentum expression. Same way here, these two expressions will be helping us to get the relation anytime if you want to find P in terms of Q dot, P dot in terms of Q, and the dots here are representing the derivative with respect to time, differentiation with respect to time. So you can write it as delta Q upon delta T. You can write it as delta P or dP upon dt. Please tell me in case if there is Any doubt? Very good evening, Shashank. So Jishmita, today we will not be having the special session, but in upcoming days we will be having. Done? Okay guys, next thing. If I'm going to talk about the next thing here, that's simply related to the Hamiltonian part, that is the total time derivative. If you want to find for any given function, for example, total time derivative of the function a, okay, with respect to t we will find because it's the total time derivative. So you have to consider its Poisson bracket with h, and you have to write delta a upon delta t, which is the partial differentiation. So many of you will be thinking about it that, oh, why it's here like this and what is this actually the Poisson bracket? So curly brackets are representing the Poisson bracket. What are the Poisson brackets? I will tell you. How to simplify them? I will tell you. So as you got to know that Hamiltonian is the function of generalized coordinate, generalized momentum and time t. So when you find the Poisson bracket of any two functions a and b, that will be what? First function, partial differentiation with respect to the position operator, or just you can say the generalized coordinate, and then other one with respect to the generalized momentum minus first one with respect to momentum and second one with respect to the position. So observe it very well. Get to know about the sequence. First, second, QP, PQ with a negative sign. So we are keeping the sequence for the numerator part same as first, second, okay? But denominator we are changing QP, PQ with a negative sign. So that's how the differentiation you have to take there, and this is the simplification or simplified expression for the Poisson bracket. At the same time, if we are going to talk about it, if let's say we are having the x, y and z different coordinates present here, so we will have to consider delta a upon delta x, delta b upon delta px, delta a upon delta px, delta b upon delta x, then plus sign in between, okay, plus sign here. Then if I am writing it for x, px, x, px, qx, like just q can be replaced with x. Same way for y, I will write all the terms. Same way for z, I will write all the terms. So this is how we will be writing for all the different coordinates, that how we will write the complete Poisson bracket expression. Okay, that's the way. But one you are going to prepare, that will make everything else simple and easy for you. So when you will be finding the total time derivative of any function, in that case you have to take the Poisson bracket, because this can represent anything. Means at different places they can give you this notation for different things. It can represent different points and different things. So here when I'm using these brackets, I'm telling you I'm taking them as the Poisson bracket. Means whatever explanation will be going on, whatever discussion will be going on right now, that will be just about the Poisson bracket and no other thing. Neither commutator bracket, no other bracket, just about the Poisson bracket. In case I will be using it directly here and I'm not going to tell you that what it is representing in case, okay? So in that case, what will happen? Oh, actually what's happened here? So in that case, you may get confused. You may be saying like, what is this actually? Because I'm not going to tell you in that case. But when I have specified, I have mentioned that, okay, it's representing the Poisson bracket, then it is representing the Poisson bracket only, nothing else, and all the properties we will be considering regarding that will be same. Okay, let me know in case if there is any doubt anybody is gonna have. Now once it's clear, we can talk about few more points. If any time we are having any function given to us, okay, any function, random any function, and we want to know whether it's a conserved quantity, whether it's a constant of motion or not. So in that case, what I have to do, I have to consider, just a second guys, I have to consider the Poisson bracket of that function, okay, with Hamiltonian, and if I get this value equal to 0, I will say that the function is conserved or constant of motion. Please tell me if in case you are gonna have any doubt or difficulty anywhere. This function is conserved or constant of motion, okay? Yes, Shashank, clear? So please let me know guys, is that clear to everyone or not? Once you got it, there is the next point you have to consider, which is about the relation between the Lagrangian and Hamiltonian. So if let's say sometime you are having the Lagrangian given to you and you want to find the Hamiltonian with that. So Hamiltonian is equal to summation over I qi dot pi and minus L. Done? So Lagrangian, if you know that and you want to find the Hamiltonian, you can use this formula or you can use this equation and you can get the answer. Why summation over I has been taken here? Why I didn't write it just as q dot and p? Because we can have the different coordinates present there. Means q can be as x. So x dot px plus y dot py minus L. Same way I can also have x, y and z. So I'll be writing all three. That's why the summation has been taken. In case I will just be having one coordinate involved or present there. So I will write only one. I will not be writing this one then. Let me know in case if you are going to have any doubt. Otherwise, if you are getting it, that's great. Now I would like to tell you about a trick, and that's the last point discussion we will be considering. After that, we will be ready to work on many questions and many concepts. Okay, we will be preparing. Even after this, many other concepts are there. For example, the generating function concept, the new Hamiltonian, the canonical transformation. We'll talk about them as well, but one by one, all the concepts we'll keep on considering. So let's talk about the next one now, which is the trick. It's the trick time. So basically, if we are having the, let's say, Lagrangian given to us, which is half and let's say x upon m x dot square, okay, minus mgy. So in general, the standard potential energy expression everybody knows, that is mgh. The same expression I'm using here, give me a second. Clear? In this case, what will happen now? In this case, I need to consider that this is the kinetic energy minus potential energy. And I can easily identify here that this is the potential energy and this is the kinetic energy. So in this case, if I have to consider it as, let's compare it with half mv square minus potential energy v. So I can get the m value from here. Keep on observing the steps and whatever I'm telling you, just focus on that part. So half mv square, this is m now. So in that case, what I have to do, I'll be writing, let's say I want to write the Hamiltonian from this expression. So I will write it as px square because the x component or x coordinate is present everywhere upon 2m. So at place of m, what I'm getting, that's x upon m, and then plus potential energy, which is mgy. This is how we will be getting it. And now what I have to do, I just need to simplify it and I will be getting the answer. Same way, instead of having the Lagrangian, I can have the Hamiltonian given to me too. So in that case, I will be comparing it with p square upon 2m form, its kinetic energy. If it is easy for me to identify the kinetic and the potential energy terms separately, I'll do that comparison, okay. And in that case, what will happen? I'll be getting the mass value. I'll just put it back in the expression of half mv square. And this is how I can get the kinetic energy for the Lagrangian. And I can just put the potential energy like that with the respective sign. For example, L is equal to T minus V. So I have to put the V there. Yes, Shashank. And H is equal to T plus V. So I have to put the V there. Please tell me in case if there is any doubt anybody is gonna have. So we are doing the comparison of kinetic energies with half mv square and p square upon 2m. Let me know in case if you are gonna have any doubt anywhere. We will be trying to consider it. And that's how we are having all the concepts for solving the questions right now in the session. Okay, let me know, is this clear to everyone? If there is any doubt anybody is gonna have, we will be talking about it. Just go through all the points. While if it is clear to you, on Wednesday now when we will be having our next session, I'll be discussing the questions based on these concepts, these points which I have covered in the session today. In the next session, along with the more new concepts, means many other concepts I'll be including there, I'll be discussing there, and then I'll be taking more important questions in the next session now. Okay, so Lagrangian, Hamiltonian, Poisson bracket, conditions, trick, all that we have considered here right now. Let's keep it this much in the session, guys. Thank you so much everyone for joining this session. One more thing I would like to tell you, if anybody is there who wants to join the regular live classes of well-structured and well-planned courses by the top educators, then guys, you can take the Unacademy Plus or the Unacademy Iconic subscription. And even in upcoming days, many new courses by the top educators will be starting on Unacademy. So if you don't want to miss these sessions, these courses and the classes by the top educators, then you can take the Unacademy Plus or Iconic subscription. They will be helping you a lot to learn new concepts, tricks, to get the right approach to solve the questions in very less time. And whenever you will proceed further to take the subscription, you can use and apply the referral code, that's Anjali A Live, as mentioned here on the screen. And by using and by applying this referral code, you will be able to get the 10% discount in the total Unacademy subscription amount. Let's keep it this much right now in the session, guys. And thank you so much everyone for joining this session. Okay. Thank you everyone. I hope each and everything is